The title of today's paper is Holistic Analysis of Urban Water Systems in the Greater Cincinnati Region, 2, Resource Use Profiles by Emergy Accounting Approach, published in the Water Research X, in 2019. With increasing populations, mounting environmental pressures and aging infrastructure, urban water and wastewater utilities have to make investment decisions limited by both economic and environmental constraints. The challenges facing urban water systems can no longer be sustainably solved by traditional siloed water management approaches. A central premise of contemporary urban water management paradigms is that in order for urban water systems to be more sustainable and economical, an improvement in resource use efficiency at system level must be achieved. This study provides a quantification of the total resource use of a typical urban water system exemplified in Greater Cincinnati region from raw water extraction for drinking water to wastewater treatment and discharge, providing a better understanding of resource expenditure distributions within the system and a necessary benchmark to which future system improvements can be compared. The Emergy methodology was used so that the total environmental work required to produce disparate system inputs could be expressed using a common unit. The results were compared to the concurring life cycle assessment, LCA, and life cycle costing, LCC, results of the same system. Emergy results highlight drinking water treatment and drinking water distribution as two resource-intensive stages, with energy for pumping and chemicals for conditioning representing the greatest inputs to the former and energy for pumping and metals for piping representing the greatest inputs to the latter. For wastewater collection and treatment stages, aeration and sludge handling were identified as the highest Emergy unit processes, mostly due to energy use. Comparison with LCA results substantiate the environmental concerns associated with energy use in the drinking water treatment and distribution stages but indicate that environmental burdens associated with infrastructure are more dependent upon upstream resource use rather than downstream environmental impact. Results from Emergy, LCA and LCC point towards aeration and sludge handling as two unit processes on the wastewater side that are particularly costly and environmentally impactful. Results in total are used to suggest alternative strategies that can alleviate identified environmental burdens and economic costs.